Welcome to 4.2, Solving Quadratic Equations, Inequalities, and Systems. The first thing I want to highlight is if you are asked to find the x-intercept or the root or the zero or the solutions, you are going to go through these methods. They all mean the same thing. We're going to follow the procedures we learned today. So first, our objective is again to solve those quadratic equations, inequalities, and systems algebraically and graphically. So let's focus on solving quadratic equations by graphing. So use the graph to solve the equation x squared minus x minus 6 equals 0. Well, I always suggest taking this and turning it into two equations. So I'm going to have y equals x squared minus x minus 6, and I'm going to have y equals 0, which is just the x-axis. And when you get the solution to two equations, it's going to be the intersection. So for my first problem, my solutions are going to be negative 2, 0, and 3, 0. If I do the same thing for number 2, I have y equals negative 2x squared minus 4x minus 2, and I have y equals 0. And the only place my quadratic intersects with y equals 0 is at negative 1, 0. So I only have one solution in this instance. And this is something called a double root or a bounce. Basically, your quadratic touches the x-axis and bounces off of it. It's going to be a double root when it comes to factoring. For number 3, use the graph to solve the equation. I'm going to have y equals x squared plus 2x plus 4 and y equals 0. And if you notice, my quadratic is above that y equals 0 line. They are never going to intersect. So in the case of quadratics, we don't just say no solutions, we say no real solutions. And we'll get into what real means in a future lesson. So now we're going to solve quadratic equations by factoring. The first thing we have to know is the zero product property. If a times b equals 0, then either a has to be equal to 0 or b has to be equal to 0, or both of them are equal to 0. And we're going to use this property to solve our quadratic equations. For number 4, we are going to want to move everything to one side. So I subtracted 12 from both sides. Now, I always suggest checking for a GCF, which our problem does have one. It has a GCF of 2. So I'm going to pull a 2 out, leaving me with x squared minus x minus 6. Now I'm going to have to split my middle term. So I'm going to want to draw either the t chart or the x chart. I want it to multiply to be negative 6 and add to be negative 1. Those two factors would be negative 3 and positive 2. So I'm going to go ahead and split my middle term, and I'm going to do my 4-term grouping. So I group the first 2 terms together, I group the second 2 terms together, giving me my inside parentheses. And if you notice now, both terms have x plus 2 in common. So I'm going to pull x plus 2 out to the front, and I'll be left with x minus 3. Don't forget about the 2 that you factored out originally. Now, this should be something you're comfortable with from 4.1. Here is the 4.2 part. So I have my zero product property that says any of these terms have to be equal to 0 in order for the whole thing to be equal to 0. So what I'm going to do is I'm going to take every factor and I'm going to set it equal to 0. Now the issue with just 2 is there's no variable to solve for, so we're going to ignore it. I have x plus 2 equals 0, and I have x minus 3 equals 0. So when I solve for x, I should get x equals negative 2 and x equals 3 as my final answer. Looking at number 5, I'm going to go ahead and move everything to one side, and I see that I don't have a GCF. So I'm going to go ahead and start by splitting my middle term. So I'm going to want it to add or multiply to be 27, because 9 times 3 is 27, and add to be 28. And the factors that do that are positive 27 and positive 1. So I'm going to rewrite my middle term as plus x plus 27x. Going to do my grouping, giving me x times 3x plus 1 plus 9 times 3x plus 1. They both have 3x plus 1 in common now, so I'm going to pull that out, and I'm left with x plus 9. I'm going to set each factor equal to 0. And I'm going to get x equals negative 9 and x equals negative 1/3. For number 6, I'm going to do the same thing. The only difference here is I do not have a 0 on one side. If you are asked to solve, that means you are looking for an x-intercept. So what we're going to do is we're going to take f of x and plug in y equals 0. So it's just going to be 0 equals x squared plus 10x plus 25. Going to go straight to my x chart so that I can rewrite my middle term as plus 5x plus 5x. Going to do my grouping, which is going to give me the factors x plus 5, x plus 5. So the factoring should start to pick up in speed. It should be something that you get more and more comfortable with as we do more problems. So now I'm going to set, well, if both factors are the same, you only have to set one of them equal to 0. Going to get x equals -5. Now, this is one of those examples of a double root where it hits the x-axis and bounces off. For number 7, I do notice that I have a GCF. So first thing I'm going to do is rewrite this with 0 in front, and then I'm going to pull out my GCF. So all of my terms have a 2x in common. So I'm going to pull that out to the front, leaving me with 2x squared minus 11x plus 12. Going to work to split my middle term. It had to multiply to be 24, add to be -11, which would have left me with the options of -8 and -3. Going to do my grouping. So the GCF of my first group was x. The GCF of my second group was -4. Now they have a common term, so I pulled 2x minus 3 out in front, and I was left with x minus 4. Don't forget about the 2x we factored out as the GCF in the beginning. Now I'm going to set all three factors equal to 0. So I have 2x equals 0, 2x minus 3 equals 0, and x minus 4 equals 0. I'm going to go ahead and solve all of these, and notice in this case, I do have an answer. With my first problem, we said 2 can't equal 0, so we ignored it. Here, 2x can equal 0 if x is equal to 0. Don't forget about this term. Okay, now we are going to solve quadratic inequalities by factoring. So the first thing I want to do is go over our steps. We're going to move all of our terms to one side, and we're going to factor. We're going to solve and find our critical points. Again, these are our x-intercepts, our zeros, our roots, whatever you want to call them. We're going to draw a number line and put our critical points on it, and then we're going to figure out where 0 is in terms of those critical points. And we're going to plug it in and see if it ends up being true. Now, if when we plug in x equals 0 and it's true, and it happens to be located between our two critical points, we're going to shade everything in between those 2 points. If it's outside of our 2 critical points, either on the left-hand side or the right-hand side, we're going to shade both the left and the right. And for if x equals 0 is false when we plug it back in and it's located in the middle, we're going to shade outside. And if it's located outside, we're going to shade inside. Now, we will be writing our final answer in interval notation, and you'll be able to determine if it's going to be a parentheses or a bracket based on the problem. So it's going to depend on what the inequality looks like originally for us to determine that at the end. So let's go ahead and give this a go. For our first problem, I'm going to already see all of my terms are on one side, so I'm going to start by factoring. The factoring step is going to start picking up. I split my middle because -7 multiplied, -6 added. The only terms that works with is -7 and +1. Split my middle, did my grouping, and I got my factors to be x plus 1, x minus 7. So I'm going to set both of these factors equal to 0 to get my critical points of x equals -1 and x equals 7. So I'm going to put these two numbers on a number line. Got a little bit ahead of myself, so we're going to have a spoiler. -1 and 7. So now I need to test the point 0. So 0 falls in between -1 and 7. So when I plug 0 back into my original equation, this is going to cancel out, This is going to cancel out, leaving me with just -7. And 0 is greater than -7, so it's true. So I'm going to shade everything inside, in between my two critical points. That's going to give me my final answer of -1 to 7, parentheses only, because my original inequality has no equal to sign. For number 9, we are going to go through the same process. I'm going to move everything to one side, and I'm going to factor. So with this factoring, I don't have any GCF, but I want it to multiply to be -8 and add to be -7. So that's going to be -8 and +1. So I split my middle term. I did my two groupings. The GCF of my first group was x. The GCF of my second group was -4. So my two factors were 2x plus 1 and x minus 4. Going to set these equal to 0, and I'm going to get my two critical values of x equals -1/2 and x equals +4. I place them on my number line. I figure out where 0 is in relation to them, and I'm going to plug 0 back in to my original inequality. And when I do so, I end up with -4 is greater than or equal to 0, which is false. So if I go back to my rule, if it was false and my 0 is in between my critical points, I'm shading everything on either side, on the outsides. So my solution area is from -infinity to -1/2 with a bracket because we have an equal to sign, all the way union because we're skipping over these values to 4 with a bracket to infinity. For number 10, we've got a little bit of work to do. We're going to subtract 4x squared from both sides, which is just going to leave me with x squared. I'm going to subtract 26x from both sides, which is going to leave me with -10x. And the 21 is just going to stay exactly as it is. Going to go through my factoring step. I end up with the factors x minus 3, x minus 7. So I'm going to set both of these equal to 0, which is going to give me x equals 3 and x equals 7. So I placed them on my number line, found out where 0 was, plugged 0 back into my original equation, and I got a false statement. 21 is not less than 0. So when it's on the outside and it's false, I'm going to shade everything inside between the two critical points. So my solution is going to be from 3 to 7 with parentheses only because there is no equal sign. Okay, last thing we're going to cover is quadratic systems. So when you are doing it algebraically, you're going to want to set your equations equal to each other, move all of your terms to one side, and then we're going to go through solving by factoring. So I have my system here. The first thing I'm going to do is set my two equations equal to each other. I'm going to move everything to one side, so I'm subtracting 2x and I'm subtracting 6, giving me 2x squared plus 2x minus 12. I'm going to then factor. So again, factoring is going to have to pick up. So I went ahead and did my GCF, 2x squared plus x minus 6. I'm looking to see what multiplies to be -6, what adds to be +1. That was -2x and 3x. So when I did my grouping, I ended up with the factors x minus 2, x plus 3. Don't forget about the 2 in front. Going to set all of my terms equal to 0. And again, if you don't have a variable, it's not going to matter. We're going to cross it out. X minus 2 became x equals 2. X plus 3 equals 0 became x equals -3. Now, normally this would be a stopping point when you are just doing a regular solving quadratic problem. But when you're solving a system, you have to find the x value and the y value. So I'm going to take my two x values and I'm going to plug them back in. The easiest equation to plug them into is the second one. So I'm going to plug them in. 2 times 2 is 4, plus 6 is 10, and 2 times -3 is -6, plus 6 is 0. That should be an equal to sign. Equal to 0. So my solutions are the coordinate or ordered pairs 2, 10, and -3, 0. For number 12, I'm going to do the same thing, but first, I have to rewrite my second equation as y equals negative x plus 4. Going to go ahead and set them equal to each other. Then I'm going to move everything to one side. And notice that my plus 4 and my minus 4, when I subtract from both sides, cancel out. Now, don't get caught up in a problem like this. Approach it like you would any other. They have a GCF. Now, I said that the GCF was negative x, and I'll show you the other way in just a second. Negative x, if I pull that out, I'm left with x minus 3, and we're going to set each of these factors equal to 0. So I have negative x equals 0 and x minus 3 equals 0. So x equals 0 and x equals 3. Now, just a brief moment, you don't have to do it both ways, but let me show you what would have happened if I factored out an x only. So if I just pulled out an x, I would have been left with negative x plus 3, and look, I still get x equals 0 and x equals 3. So let's go ahead and find our y values. So when I plug in x equals 0 into my second equation, I got y equals 4. When I plugged x equals 3 into my second equation, I got y equals 1. My two solutions are the ordered pairs 0, 4 and 3, 1. The last thing we'll cover is how to solve quadratic systems by graphing. And again, when you have two equations graphed on a coordinate plane, and you're looking for the solution, you are looking for where they intersect. So for number 13, I can see that my first intersection is at negative 3, 0, and my second intersection is at 1, 8. So my two solutions are negative 3, 0, and 1, 8. Well, for number 14, it doesn't look like my quadratic and my horizontal line are ever going to cross. So because of that, I'm going to have no real solutions. And again, in a couple of lessons, we're going to go into the idea that while it might not have any real solutions, we could have some imaginary, and this one actually has two of them.